320,000. The sample that I get says 300,000. Is that difference of 20,000 due to just randomness of the samples I got, or is it due to that there's actually a difference between the two? And what you want to think of about that is think about coin flips. I'm going to come back to coin flips quite a bit because everyone understands them. If I flip a coin 100 times, I expect to get 50 heads. But I don't always get 50 heads. Actually, it's very unlikely that I get exactly 50 heads. Sometimes I get more than 50, sometimes I get less than 50. Now, if I flip a coin 100 times and get 53 heads, we don't think that's unusual. Okay? The coin's fair. The chances of getting 53 heads is not something that's unlikely. Okay? So I get 53 heads flipping a coin one time. Then you flip a coin and you get, let's say, 48 heads. Okay? Does that mean I'm better at flipping heads than you are? Because I got 43 and you got, or excuse me, I got 53 and you got 48? Not necessarily. Okay? We're probably equally the same, just the breaks went my way. Okay? Well, we could think about the same thing in terms of housing prices. Okay? That is my sample, is the difference in my sample just due to the randomness of what houses got picked, or is there a real substantial difference between the two? And we'll learn how to do that with hypothesis testing. And then where we're going to spend most of the rest of this class is dealing with regression, trying to understand the relationships between the individual variables. So how much does the size of a house matter? How much does the age of a house matter? How much does having a finished basement matter? Does it matter that your house has hardwood floors throughout? We can think about all of those things. How do each of those individual things affect the selling price of a house? Because if I'm thinking about, do I want to add a deck to my house or do I want to finish my basement? Okay. And maybe if I'm concerned about resale value, knowing that piece of information might give me a good clue as to what should I do. So what we're going to do is we'll do a little bit here and then we'll spend a lot of time in inferential statistics. The link between these two is probability. What we're hoping to do is we're going to use probability to take information from descriptive statistics and make inferences about the entire population. So what I can do is I can go out and interview college students about all types of things. So I could ask you about how much time do you spend online? I could ask you about how much sleep do you get? I could ask you about how much do you work? I could ask you, I guess, really anything. Okay. And then what I could do is I could maybe, say, okay, well now that I got this representative sample, or at least I hope it's a representative sample of students, what can that imply about all college students? Okay. Or at least all Towson students? So that's where we're going with this, is we're going to be using probability as this link where I could say these events are likely versus these events are, I typically like to use the word improbable. Okay? That hypothetically it could happen, just like there's a chance a meteor could be screaming towards the Earth and will crash down here later today or something like that. It's not very probable, actually. It's extremely improbable, but it could happen. And so that's where we're going. Any questions? Everyone feel comfortable about what we're trying to do in this class? Or at least the idea of what I'm talking about with variation, because we're going to come back to that as a theme. So, let's talk about your project, because your project really plays into this. Your project is a chance for you to go out, collect data, and then tell me a story about that data. That's what I want you to do. That one time I was teaching this class, I was teaching in North Carolina when I was at ECON, and I was teaching it to a bunch of MBA students. I started off, I said to them, what do you hope to gain from this class? I got a number of responses. I thought, unlike undergraduates, they're in an MBA program, so they have, I don't say more of a goal, because you all have a goal. But they're using this business, in their everyday work already. So I wanted to see what they want to say. And I remember one student said to me, I want to learn how to lie with statistics. I suggested that was probably not the best idea. But I kind of understood his point also of what I wanted to learn was how to be able to tell a story with statistics. In your first statistics course, you focused a lot on technique in terms of how do you do this and how do you do this. So how do you do a hypothesis test? How do you set up H0 and H1? How do you find out your T statistic or your Z statistic and your Z test or your T test? And then how do you have a critical value, decision rules, and all of this good stuff? And that all has a place. But in reality, what we want to be able to do is collect data and then be able to go out and explain what does that data mean. And that's what I want you all to be able to do at the end of this class. Because when you get out into the workplace, a lot of the stuff with statistics is done on the computer, and we'll actually be using the computer for all this. So knowing exactly how to do everything is not necessarily as important to me as you being able to actually manipulate data and then come up with a coherent story about it. And so that's what your project is. Now, your project, you're going to be working in groups. I'll typically have groups of somewhere between 2 and 4. I don't like groups more than 4. I do like people working at least with someone else. Probably what we'll do is after the break, we'll set up groups. Today is a day that there are quite a few people in your class that are missing today. I guess they start their spring break early. So we'll set that after break and after everything that happens then. But what you're going to do is, the first thing is you need to form a question of some sort. Now, the question can be pretty much anything, but what you're going to want to be able to do is form a question where you can collect data about it and then be able to answer that question. So, for example, you might ask the question, what contributes to a student's GPA? Okay. So you could say, why do some students do better than other students? So what you would want to think about is, okay, well, I'm trying to predict a student's college GPA. And then what you would want to think about is what things contribute to a college student's GPA. Well, one thing may be their high school GPA. It's not universal, but a student who had a very high GPA in high school is more likely to have a high GPA in college. So not necessarily always the case. You have some students who did well in high school who don't do well in college, and some students who maybe didn't do quite as well in high school but do a lot better in college. But typically that's probably not the worst predictor. Okay? So maybe something about high school GPA. Maybe you're interested in